this is the last thing that you'll be doing for the rest of the year. The remaining 2 lessons is slight variations on this, but try to get fast at this, the Hungarian algorithm. We're only doing minimization now. So the exercise that you're going to do today after I've taught this, you're doing exercise 12B3, but you're only going to be able to do 1, 2, 3 today. We'll finish off 4, 5, 6 on Friday. So what we did before with the swimming situation, we tried to solve it by eye, okay? We solved it by trial and error, but we left it a bit iffy because one of our students here thinks he has a better option. So you need a better way of finding the best answer without having questions about it later. So the Hungarian algorithm is a way to find the minimum optimal solution so it finds the lowest total allocation. What I'd like you to do, please, can you have the steps, all this blue, open beside the actual matrix that we're going to do it on so I can demonstrate each step as we go. So this is the same as before. It's still A, B, C, and D. It's the same strokes. It's the same numbers, but we're going to definitively find the answer rather than just doing it by eye and hoping for the best. So what are the steps? This is the noughts and crosses that I told you about. It's going to feel like that. It's not even maths. In each row, subtract the minimum value in that row from all the elements in the row. So we're doing rows to start off with. The top row is A. What's the smallest number? What's the minimum number in the A row? 52. So I'm going to put a little line under that. What's the minimum number in B? What's the minimum number in C? 51. What's the minimum number in D? 48. So I'm going to draw another matrix here, but that is after I've taken the smallest from each. So 52 away from 56 is going to be 4. 59 take 52 is going to be 7. 52 take 52 is going to be 0. If you're doing it right, there should be a 0 on each row because taking a number away from itself is going to result in 0. 53 take 52, 1. I'm going to take 49 from 62. 49, 59. I think that's 13. I'm not confident with subtraction. Lucky you guys have a calculator. Let's do that anyway. 62 minus 49. You're allowed it, so I'll do it. 67 minus 49, 18. 59 minus 49, that's 10. 49 minus 49, 0. Can you finish off these rows? I'll read them out for the sake of the video. 55 take 51, 4. 64 take 51, 13. 58 take 51, 7. 51 take 51, nothing. 48, 58 is 10. 12. 56 and nothing. That was step 1. If you want extra working out, you can write this. You can write take 52 to remind yourself, take 49 to remind yourself, take 51, take 48. You can do that. Doesn't matter as long as you get the matrix right. What was step 2? In each column, so we're going vertically now. In each column, subtract the minimum value in that column from all the elements in that column. Zeros are included in this. Zeros can be the minimum. So what's the smallest number in the leftmost column? 4, so I'm going to take 4. What's the smallest number in the next column over? 7, so I'm taking 7 from that column. Smallest number in this column? 0, I'm taking 0. Smallest number in the last column? Also 0. Draw another matrix where you have done that. 4 take 4 is nothing. 13 take 4 is 9. 4 take 4 is nothing. 10 take 4, 6. 7, 7, 0. 11. 7, 8, 9, 10, 11, 12, 13, 6. 12 take 7, 5. When I'm taking 0 from a column, it doesn't change the numbers. All right, that should be your matrix after the 2 steps. Step 3, noughts and crosses time. using horizontal and vertical lines, so no diagonal, you want to cover the zeros in the matrix with the minimum number of lines possible. So you want to snipe those zeros with as few lines as possible. The best approach is to cover the max number of zeros each time you draw a line. So what's the most number of zeros I can hit with a horizontal or a vertical line here? 3. There's 2 options there. It doesn't matter, as long as you're hitting as many as possible. So I'm going to do that one. What's the most number of zeros I can hit with a horizontal or vertical line here? 3, vertically. What's the most number of zeros I can hit, vertical or horizontal? I can hit 2. I can do that. How many lines did I just draw? So I just drew 3 lines, and are there any zeros left that haven't been covered? So I just took 3 lines, right? So what's part of step 3? The stars at the end of step 3 say check. If the number of lines is equal to the number of rows, we skip to step 5. How many lines did I just draw? How many rows are there? So I can't skip to step 5. I need to do step 4. What is step 4? If the number of lines is less than the number of rows, find the smallest uncovered number in the matrix. Let's find that. What's the smallest uncovered number in that matrix right now? 5. I'm going to circle it. What do we do with that smallest number? You subtract it from all the uncovered numbers. You add it to numbers that are double covered. So when there's, see how that 0 there has 2 lines crossing it? So we add it to those. And if it's single covered, we leave it alone. That sounds complicated, but we'll do that now. Let's draw a matrix here. That top left 0, it's double covered. So I'm going to add the 5 to it. So 0 plus 5 is going to be 5. This 0 here, it's single covered. So I leave it alone. 0. This next 0 to the right is single covered. Leave it alone. That 1 in the top right corner, is it double covered? So I add the 5 to it. 6. 9 in the second row, single covered. Leave alone. 11, is it covered? So I take it away. So 11 take 5 is going to leave you 6. 10's uncovered, so 10 take 5 is 5. 0, single covered, leave alone. Next 0, leave alone. 6 uncovered, take 5 from it, 1. 7 uncovered, take 5 from it, 2. 0, leave alone. 6 single covered, leave it alone. 5 is itself uncovered, so take 5 from 5, 0. 6 uncovered, take, so 1. 0 single covered, leave alone. Once you have done that, you try the lines again. What's the most number of lines that I can snipe in one go? 3 vertically. Can you see that on the right hand side of my new matrix? I can hit 3 there. What's the next most that I can hit in one go? 2 up the top. What's the next most I can hit in one go? I can hit 2 vertically. What's the next most I can hit in 2 horizontally? How many lines did that take? 4 lines. How many rows in our matrix? 4 rows. So we're done. So you can just copy that down before I go to step 5 and explain that. So once you have gotten to a matrix where you covered the zeros with as many lines as rows, what do? Find a pattern of zeros in the matrix so each row and column only has 1 0 in it. The best way that I came up with, because your book doesn't show, is you go, is it alone in its row? Question mark. Is it alone in its column? If so, yes, you circle it. Let's try that here. Let's go. That's not a 0. Is that a 0? Is it alone in its row? Is it alone in its column? Leave it alone for now. Don't circle it. Is this 0 alone in its row? Is it alone in its column though? Select it. Let's move to the next line. 9, 6, 5, don't care. Is this 0 on the right of the second line, is it alone in its row? Select it. Next line down. Is this 0 on the far left alone in its row? No. But is it alone in its column? Yes. Select it. The last one, you don't need to think about it. It's process of elimination. Because is there anything selected in this column and this row combination? So that leaves that 0 to be selected. What the hell is this pattern about? Because if I apply that pattern to the OG matrix, what was the OG matrix? The OG matrix was this. 55, 60, 49, 52. That's the best combination and you don't need to question it. Okay? Is that what Daniello got? It is. Okay? So I wanted the previous lesson to be a bit iffy because this is what you're going to do for the rest of it is you're going to get a matrix or you're going to get a little graph to make a matrix of in the exam. What is the best solution? Rows, columns, cover with lines, and then that's the best solution. So what is this saying? How do we answer the question? A does butterfly, B does freestyle, C does backstroke, D does breaststroke. Use the Hungarian algorithm to find the minimal optimal assignments to have the fastest possible team. What is that total? So 52, 49, 55, 60. Let's add those together. Ooh. Didn't realize she'd be on the video. 49, 55, 60. So we can confirm it's 1 second faster than the one that we got, but we weren't sure of. I want us to not be sure of that because this shows you why we do this method. Okay? So therefore, 2:16 seconds total for fastest team. That is the Hungarian algorithm, and that's the only thing that you're doing for the rest of the topic. What you're going to learn on Friday is how do we maximize, because this finds the smallest number. Maximizing takes one extra step, and then you do the same bloody thing. And then the last lesson that you'll have with new stuff is Monday next week. What do we do when the matrix isn't a square? Because what if it's like got 5 rows and 6 columns? Well, we just add a column and fill them with zeros, and then we do the same thing. This is the last thing you need to know, okay?